Oil Palm Part 2 Soil and Water Conservation. In field planting of oil palm, there are several techniques applied in soil and water conservation in the oil palm plantation. There are zero burning, terracing, platforming, LCC planting, and silt pit. For soil and water conservation, the variety of techniques to be adopted depend on three major factors. The first one is terrain. More hilly areas require more care and effort. Second one is rainfall. Higher rainfall areas to have more intensive soil conservation. The third one is soil. Marginal soil such as sandy soil, peat soil, acid sulfate soil, and tin-tailing soil, as well as the weakly structured soil, are more prone to soil erosion and excessive drainage. For terrain, various terrain classes is shown in the following table. There are 6 main degrees of slopes with a 6 classification of terrain. For example, a slope with a 0 to 2 degrees is considered to have a level or nearly level class. For a slope of more than 25 degrees, the terrain class is considered as very steep. Let's have a look on the terrace and platform construction. So, what are the differences between terraces and platforms? Terraces refers to the continuous benches cut into the hillside to provide a suitable planting site for oil palms. Platforms, on the other hand, is an individual terraces cut into the hillside to provide suitable planting site but are not interconnected. The selection either terrace or platform to be constructed is depends on the degree of the slopes as follows. For a slope with a 0 to 2 degrees, no platforms or terraces is required. For a slopes between 2 to 6 degrees, platforms is required in places. For a slopes of 6 to 12 degrees, the platforms are optional. For a slopes between 12 to 20 degrees, platforms are required. For a slopes of 20 to 40 degrees, terracing is required. And for a slopes of more than 40 degrees, this area is not to be planted. For a very steep land with a slope of more than 40 degrees, it should not be terraced or planted because of several reasons. The first one, the terraces will be prone to land slippage and erosion. Next, the harvesting and evacuation of crops are tedious. Also, the road and drainage and maintenance will be more expensive. Next, the management and supervision may be difficult. And finally, such development is not environmentally responsible. In terrace and platform construction, the objectives are to facilitate effective establishment, maintenance, and harvesting of palms. It also helps to minimize the soil erosion and reduce the rainwater runoff and nutrient losses. In addition, the construction helps to increase the water infiltration and conserve the moisture. It also provides each palm with equal access to light, nutrients, and water. During the terrace and platform construction, there are 2 main standards that need to be fulfilled. First, the platforms and terraces must be designed so that they do not create hazardous landslip zones or concentrated water flows. Second, a detailed assessment of cost must be completed before terracing work begins. Terracing is very costly and may be uneconomic and environmentally unacceptable. For terracing, there are several procedures involved. First, to prevent erosion, cover plants should be established on slopes as soon as after land clearing. Next, in steep areas of more than 20-degree slope, full contour terracing is essential. Then, the areas where the slopes exceeds 40 degrees should not be planted. Mechanical terracing using a bulldozer with a 3.66 meter blade is used to cut terraces of 4.27 to 4.57 meter wide where 3.66 meter wide is acceptable. The terraces should be sloped back into the hill at an angle of 15 degree to 20 degree to allow for consolidation of the spoils. The water control stop bands are installed in the drainage channel at the back of the terrace at 10 to 20 meter intervals. The purpose is to stop the lateral movement of runoff water. This figure shows the terrace in the hilly area. This figure shows the terracing activity. Next, let's have a look on the platforming. In platforming activity, there are several procedures involved. In areas with slightly steeper slopes of 6 degree to 20 degree, platforms are constructed with dimension at least 3 meter times 3 meter. The platforms should be cut at 3.5 meter wide base with a 15 degree back slope. The platform area should be 12 meter square with a dimension of 3.5 meter times 3.5 meter to 20 meter square with a dimension of the 4.5 meter times 4.5 meter. The LCC should be planted along the spoil and face off the slope as soon as the platform construction has been completed. This figure shows the before and after platformings being constructed. This figure shows the example of platforming in the actual field area. Next, let's move on to the LCC. LCC refers to the leguminous cover crop. This LCC is purposely planted in the field in the land preparation. There are several types of the LCC, including the Centrosema pubescens, Puraria fascioloides, Calopogonium mucunades, and Mucuna bracteata. The three most common LCC normally grown in the oil palm estates in Malaysia are Mucuna bracteata, Calopogonium cerulum, and Puraria fascioloides or javanica. Mucuna cochinchiniensis to be planted around the shredded palm hips at the rate of 2 kg per hectare. The objectives and benefits of planting LCC includes to control the soil erosion by protecting the soil from the heavy rainfall and direct sunlight. LCC also improve the soil condition by providing mulch of organic matter in a decomposition process. LCC also able to retain the moisture and reduce the soil temperature. LCC helps to reduce the nutrient leaching and surface water runoff. It also provides the nitrogen through symbiotic fixation of the atmospheric nitrogen, approximately less than 300 kg nitrogen per hectare per year. It also prevents rhinoceros beetle from breeding in felled palm trunks, and it also able to control the weeds due to the competition against the weed species. In LCC establishment, there are three main standards that need to be fulfilled. First, the LCC must be uniform. Second, the LCC establishment is in the interrows and between palms. Third, the circle around the palms are weeded to prevent the competition from the LCC. In LCC establishment, there are several procedures involved. The first one is the seed scarification. In this procedure, the seed coat is treated to allow the water absorption, which will trigger the seed germination. The purpose is to reduce the thickness of the seed coat without damaging the germ. This can be done in three ways. First is by soaking the seed in hot water. Second is by diluting the seeds in the acid. And third, We can tumble the seed in a rotary drum mixed with clarifying agent, such as finely sand, for 6 hours. The next step is the seed inoculation with rhizobial inoculums. The roots of LCC form a nodules with a symbiotic bacteria that is able to fix the atmospheric nitrogen. The inoculation process is to ensure that the plant roots able to nodulate. In replant areas, it is usually not necessary to retreat with inoculants. In this procedure, a slurry is made using 50 grams of rhizobium inoculant in 500 ml of distilled water. This is enough to treat 10 kg of LCC seeds. The slurry is then poured evenly over the scarified seeds and mixed thoroughly. The slurry is then mixed together with the rock phosphate on the same weight. For example, 10 kg of seeds will require 10 kg of rock phosphate. The inoculated seeds need to be sowed within 3 days. This figure shows the step-by-step procedures for LCC planting. First, mix all the LCC seeds in a big pail. Then, the LCC seeds need to be soaked in the water with a temperature of 75 degrees Celsius. This can be done by mixing the 2 parts of boiling water with 1 part of cool water for about 2 hours. After 2 hours, drain out the water. The seeds are then mixed thoroughly with rhizobium inoculants with a ratio of 50 grams to 10 kilograms of seeds. Then, the slurry is mixed together with rock phosphate on the same weight. For example, 10 kg of seeds will require 10 kg of rock phosphate. Next procedure for LCC establishment is the seed sowing and planting. Generally, for 1 hectare of planting, 7 kg of LCC seeds are used. The ratio are as follows: 3 kg of Puraria javanica, established rapidly; 3 kg of Calopogonium mucinoides, dominate after the palm canopy closes; and 1 kg of Calopogonium cerulum, dominate after the palm canopy closes. To achieve the required sowing rates and even distribution, it may be necessary to add sawdust or sand to the seeds mixture with a ratio of 1:1. In a flat and undulated area, 2 double drills at 0.6 meter apart, leaving a space of about 1.8 meter between the 2 double drills, are made at the interrow. In the contoured area, the LCC is sown between the terraces and contour banks. This figure shows the LCC establishment. Within a distance. The drills can be made either manually or mechanically. Then, the LCC seed mixtures are sown. The drills are then covered with 1 cm of topsoil. Monitor the amount of seeds used and the area planted by each worker to determine the correct sowing rate. The germination occurs after 5 days of sowing, and the establishment of the LCC canopy should be observed after 3 months. This figure shows the initial establishment of the LCC in the field. This figure shows the establishment of the LCC after 3 months. This figure shows the establishment of the LCC in the actual field area. This figure shows the good ground cover using the LCC. Moving to the next soil and water conservation is the silt pits. As a further measure to control the soil erosion and surface runoff, the silt pit should be constructed. The silt pits are constructed by digging a hole on slopes of undulating areas, which is one side of the road at points joining to the terraces. This can be considered in areas with lateritic soils and marginal soils. It can be spaced at 20 to 30 meter intervals depending on the severity of the erosion and velocity of the surface water during the rainy seasons. This figure shows the example of the silt pits. This figure shows the example of the silt pits. The objectives and purpose of the silt pits is to provide an efficient way of reducing the speed of water flow. It able to trap the loose soil, thus preventing it from clogging up the drains. It also acts as a water reservoir for spraying and any other water-related field operations, and the silt pits able to retain the soil moisture. There are several procedures involved in the silt pits construction. Depending on the severity of the erosion, silt pits are constructed on one side of the road at point joining to the terraces, spaced at 20 to 30 meter intervals. The size of the pit can be 6 meter length, 1 to 1.5 meter width, and 0.6 to 1 meter depth. It could be extended about 2.5 meter into the stacking rows. For water retain that can be utilized by the palms, the silt pit should not be deeper than 1 meter. This is because the feeder roots of matured palms is around 60 to 100 centimeter. The silt pit should also be constructed in between palms across the width of terraces, which are uneven or sloping, where stop bands are either non-existent, non-functional, or ineffective in checking the lateral flow of water on such terraces. Next, let's move on to the road construction. The road system should be laid out after lining but prior to the field planting. There are several road components definition. The first one is a collection road with a width of 4.3 meter. Collection road is often aligned at the right angles to the direction of the planting rows. This is the road which the harvesters bring the fresh fruit bunches for collection. It is often spaced at intervals of 800 to 1000 meter depending on the field conditions. The next one is the main road with a width of 5 meter. This is the road that connects the number of minor collection roads. It is the main route through the planting for transporting fresh fruit bunches to the mill or ramp. It should be graded, chambered to permit effective water runoff, and surfaced with laterite or other suitable materials. The space is often at intervals of 300 to 400 meters, depending on the field conditions. In road construction, all roads must be chambered to prevent water accumulation on their surface. The roadside pits or sumps should be constructed at both sides of a steep road to channel the excess water. The recommended dimension is 1.5 meter length times 1 meter width and 1 meter depth. This is the example of the chambered road. This figure shows the roadside pit or sump, a diversion of channel of water flow. This figure shows the typical road layout on a nearly flat land. Next, let's have a look on the drain construction. There are several drain terminology. Outlet drain is to receive water from main drains and carry water beyond a tight gap or estate boundaries. Main drain is to carry water from a number of collection drains and running directly to the outlet points. The collection drain is to collect water from the subsidiary drains. The subsidiary drains is run parallel to the pump rows. The following table shows the general drain dimensions and intervals. The foothill drains are constructed at the fringe of the hills where the slope changes abruptly. This will act as a break for the surface water that is flowing downhill. The drain stops or blocks or weirs to add in water retention may be necessary for areas with low rainfall. The typical drainage pattern in oil palm estate is shown as follows. Next, let's move on to holing. Planting holes may be dug either manually or mechanically by using a post hole digger. The holes should be dug about 15 cm deeper than the height of the soil core in the polybag to assist the initial root penetration. In heavy clay soil or very friable sandy soils, the holes of 60 cm times 60 cm times 80 cm should be dug manually. Hole-in-hole planting technique is practiced in pit soils and marked areas to avoid leaning of the oil palm tree when it grows up. A hole about 3 meters in diameter and 0.5 meter deep is dug at planting point for the first hole. Another standard hole with measurement of 60 cm times 60 cm times 80 cm is dug in the center of the first hole. The seedling is then planted in the bottom of the larger hole with the ball base level with the soil level in the bottom of the larger hole. The next activity in field planting is the transportation and handling of seedlings. The polybag seedlings should be thoroughly watered before leaving the nursery. For advanced planting material, which is over 16 months, the etiolated fronds and spear should be pruned prior to the field planting to minimize the transpiration losses and wind damage through the spear snapping. Where necessary, fronds may be tied together in a bunch before seedlings are transported. This figure shows the transportation and handling of seedlings in the field. Next, let's move on to the planting of oil palm seedlings. The objectives of the planting of oil palm seedlings is to achieve the rapid palm canopy development and minimum time period to the start of harvesting. It is also to establish a full stand of healthy palms with no transplanting shock or palm losses and to minimize the requirement for supply planting. In this activity, there are several standards that need to be fulfilled. First, no abnormal palms are planted. Second, polybags are removed at the time of planting. Third, in mineral soils, palms are planted so that the base of the palm ball is level with the surrounding soil. Fourth, soil is firmly and evenly consolidated around the base of the seedling. Fifth, support the leaning palms with a stake. Several procedures involved in the planting of oil palm seedlings. First, the hole is filled with soil until the bulb is level with the ground. Then, the soil is fairly consolidated but not compacted. The palm seedling is carefully put upright in the hole and rechecked it is at the correct depth. The polythene bag is carefully cut away. Next, the soil is packed around the palm a few centimeters at a time by consolidating it firmly. The roots should not be damaged. Once the hole is full, the cut polybag is placed around the planted palm. It will serve as mulch and also provides supervisory staff with visual check. 500 grams of CIRP, which is referring to the Christmas Island rock phosphate, should be incorporated in the planting hole prior to planting. This figure shows the planting of oil palm seedlings, where the soil from the top in one heap and soil from the bottom is in another heap. The bottom soil now is on the top and the top soil now is at the bottom. In severe attack, wire netting is placed to cover the seedlings from enemies such as wild boar, rats, porcupine, and others. This figure shows the immature oil palm plantation, approximately around 1 to 2.5 years age. This is the matured oil palm plantation with an age of 3 years and above. End of part 2.